you need to draw your free body diagrams because they are the ones which kind of give you an idea what's happening. So look at this. This is our free body diagram. That's our 45 kilo, and then we want to list the forces that are acting on this, all the forces acting on this 45 kilo. So now I'm going to put it in two forms. Let's look at the same diagram we're having. The first force that is acting on the diagram, the one that you must always remember, is your weight. Remember, use straight lines, use a ruler. So this is the weight, which is W or FG, whatever you want to use. So this is the weight, but now the weight is always opposed with the normal force. These two are always opposing each other. So this is our N or Fn, depending what you want to use. So that's the normal force. The question says calculate the magnitude of the what? Of the normal force. But the interesting part here is there is an extra force which is pulling at an angle, that 90 degrees. You can't ignore it. Now let us look at the next one. Now we are looking at question number what? We're looking at question number 3. Now question number 3 says, if you're doing this, as I said, I'm just moving a bit quicker there just to get this done in as short time as possible. A box with a mass of 45 kg is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves at a constant velocity. When you see that constant velocity, don't forget acceleration there is equal to 0. So that's why they are putting that in capital letters, because they want you to understand there is no acceleration in that. Now define the term kinetic frictional force. Kinetic frictional force. This is what? This is Fk. So what is it? You are saying it is the force that opposes the motion of a moving object relative to the surface. It is the force that is opposing the what? Is the force that is opposing the motion of a moving object. So it is opposing motion of a moving object. So that's the first part. And then we're saying what? How? What is the relative? Saying relative to the surface. Okay. But you can do your definitions. Very important. You need to know your definitions. It's very important. This you need to just grab one, hold from your textbook, and then make sure that you master your definitions. Same thing with the second one. State Newton's first law of motion in words. We're saying a body will continue at rest. Number 1, continue at rest. Keyword there. Or it will move at constant what? Constant speed. So it's either it's continuing at rest or it will move at constant, let's use the word velocity. It will move at constant velocity. And then that's the first part. Secondly, unless acted by a external force, or unless there is a net force on the object. Unless acted by an external force, unless there is a net force, unless there is a resultant force. So again, you need to know your definitions. Moving on, calculations is what I'm mainly interested. Calculate the magnitude of the horizontal component. Previously, remember the question wanted vertical. Now this one says calculate the magnitude of the horizontal component of the applied force. So look at this. It's pulled with a force. So 90 here is your F applied. That's your F applied. That's the 90 newtons. So that's don't say where is it. So calculate the magnitude of the applied force. They gave you 2 marks. Now look, when you are given this diagram, I have that and I have that. So when you're resolving, this is vertical and that is horizontal. And the horizontal we call it Fx, and the vertical we call it Fy. Now remember, Fx is linked to cos. So what is it? It is that r cos that. But what is your r? It's 90 cos 50. That's the answer there. So for that question 3, it's 90 cos 50, and then you need then the calculator to say what is 90 cos 50, which is equal to 57,85. So it's 57,85 newtons. That's what we have. Next one says calculate the magnitude of the normal force. We want to calculate the magnitude of the normal force. Now I want to pause here and just show you what's happening in this. If you had to draw, what is important when you're dealing with such, you need to draw your free body diagrams, because they are the ones which kind of give you an idea what's happening. So look at this. This is a free body diagram. That's our 45 kilo, and then we want to list the forces that are acting on this, all the forces acting on this 45 kilo. So now I'm going to put it in 2 forms. Let's look at the same diagram we're having. The first force that is acting on the diagram, the one that you must always remember, is your weight. Remember, use straight lines, use a ruler. So this is the weight, which is W or Fg, whatever you want to use. So this is the weight, but now the weight is always opposed with the normal force. These two are always opposing each other. So this is our N or Fn, depending what you want to use. So that's the normal force. The question says calculate the magnitude of the what? Of the normal force. But the interesting part here is there is an extra force which is pulling at an angle, that 90 degrees. You can't ignore it. And we said that 90 degrees has got 2 forces, the Fy, look at the arrow of the Fy. So you can come also and add it up there to say, but I have that force, which is what? The Fy, is the component. And then at the same time, I have a component of it, which is this direction, and it is the what? It is the Fx. So whenever they are talking about the magnitude of the normal force, the reason why they wanted the 4 marks is because of the Fy that is hidden. So it's your duty now to resolve the forces, to say if you are resolving these vertically, resolve or vertically. What am I trying to say? I'm saying look at all the vertical forces, and if you're looking at the vertical forces, you can say take up as positive. If we're taking up as positive, what do you see? I'm seeing the normal force plus the Fy is minus, I'll say minus the weight is equal to 0, because this object is not going up. Remember, it is being pulled horizontal, it's not flying, it's not moving in the air, so it's equal to 0. But since it is like that, you can even write this simpler and say the normal force, because plus the Fy is equal to the weight of the object, because it is not going up, it is not going down, it is moving horizontal. So on the vertical forces, we have a right just to state the part to say this formula is the one that can give you, this is the one formula. But well, doing it like that, still it doesn't give you anything wrong. Or using Newton's second law, you could have said here is equal to ma, but acceleration here will be what? Will be 0, and they need to make everything equal to 0 at the end of the day. Okay, so y from F is equal to F net is equal to ma. That's where I'm taking it. So now let's focus on this. Now the normal force, that's what they want to calculate, or Fn, normal force plus Fy. Now Fy, in as much as we said Fg was that, but Fy also we can find it. It is 90 sine 50. Are you seeing that? That is Fy, because Fx was 90 cos. So you can come here and say 90. Okay, this is 90 sine 50 is equal to weight. Now don't forget, now what is the weight? The weight of an object, W, is equal to mg, mass times gravity, and we know the mass of this object, which is what? 45. It's 45 kg they gave us there, so it's 45 times g. We're using 9.8. You're supposed to use 9.8 for your g. So now take this to the other side, so you get your normal force, which is 45 times 9.8. Now this was positive, it becomes minus. See, from positive jump the equal sign, becomes minus, so it's negative 90 sine 50. Then you can have the normal force being what? The normal force at that stage, it will be, so it's 45 times 9.8 minus 90 sine 50. Am I right? Equal to, this is 372,056. Round off, shift, setup. 6 is fixed to 2 decimal places, 2, which is 372,06. So it's 372,06 newtons. That's the normal force. Then you get the 4 marks there. Then calculate the coefficient of the kinetic friction, 4 marks. Now back again to our diagram. It's always important whenever you are resolving. So a box with a mass is pulled off this, so which means I didn't finish all the forces here. There was friction. They never said this is a frictional surface. There is friction here acting. So if there is friction, and remember the box is moving in this direction, this is the direction of where the box is moving. Now friction always opposes motion, so where will friction be going? In the opposite direction. So going back is what? Is our F. In this case it's our Fk, but it's friction. So now again, whenever we're dealing with friction, you have to resolve horizontally. You are looking at these two forces. These are the forces of interest. The vertical forces do not affect friction. Friction is only concerned with the horizontal forces. Again, if you are working on that, I can then come and say, if I'm to deal with friction here and I'm resolving, so it to be Fk, right, being the going this direction, and then minus, okay, let me just first do this. What can you say? Take what? Take right as positive, meaning the direction where it's moving is positive, which means in this case it is Fx, right, is moving that direction of Fx, and then minus, because friction is opposing, minus friction is equal to mass times acceleration. Why am I getting it? F net is equal to ma, but they told us something, constant velocity. I told you acceleration is equal to 0, so you still come and say Fx minus F is equal to 0, so which means Fx is equal to F. I think that. So we are solving in this case for F. So if you are doing it simple, we are saying friction is equal to Fx, but we know what is Fx. Fx, we just calculated it in the first part. They told us that Fx is 57,85. So you take that to say 57,85, and then friction. So we know now what is friction is 57,85. Now the next part, let me just quickly check the formulas here to see what you're given on the formulas. If you're given friction, yes, there we go. So you see it says mu k is equal to Fk over n. I think that mu k, this is the formula I want to use. Mu k is Fk over n. What is the question saying? The question here is saying you need to calculate the coefficient of kinetic friction. That's your mu k. So if I can come with the formula and say mu k here, mu k is equal to was it fk, is it, because it's f is equal to mu n. I'm used it like that, so which means mu k is equal to fk and then over n. All right, so now mu k is equal to fk, which is the same f that we found, is 57,85 over the normal force. We just calculated the normal force. We said it was 372,06, so that's what you're gonna use, 372,06. So what is mu k? Then we get that answer for mu k. It is 57,85 over 372,06, and then you get now the answer to be 0,155. 2 decimal place, shift, setup 6 2, which is 0,16. all right, it doesn't have units because it's mu. So guys, that is that. And then next question here, it says, will the coefficient of kinetic friction change if the angle of the applied force is decreased? So they're saying if you change this angle here, if this angle is changed of the applied force, maybe you make it like this, change the angle from that, it becomes like that, so that maybe the angle now is around 30 degrees. So they're saying, will the coefficient of kinetic friction change? The answer is no. Will it change? It is no. Why? Because the coefficient mu k is dependent only on the surface. Depends on surface. Okay, on the surface of the material, not the angle. So it does not depend on the angle, but depends on the surface of the material. So guys, this was that. I don't know whether it's making sense. I hope it is. So let's continue. As I said, this is the last one. I'm doing question number 5. Again, similar. A crate with a mass of 25 kg slides down a plane which is at an incline of 15 degrees to the horizontal. During the first part of the motion from A to B, there is no friction between the crate and the plane, but part B, C has a rough surface. Okay, there we're showing what is happening there. 5.1 says, draw a free body diagram of all the forces acting on the crate while it is moving from B to C. Now look at this. I will draw it just here and then finalize it. Now when you're talking with a free body diagram, what you have is the plane itself, and in the plane itself, remember, perpendicular to the plane is always the normal. Don't forget that. And then opposite the normal, straight line, must be a straight line, is what? Okay, we're gonna deal with that. Let me first not do it like that. There is always a force that is vertically or acting downwards, whatever the case. And when it's always working downwards, it is the weight of the object, which is the Fg. It is always downwards, vertically down. And then, since this block is going downwards, remember it is sliding downwards. They're saying a crate with a mass of 25 kg slides down a plane with an incline of what? Of that to the horizontal. During the first part of the motion, from A to B, there is no friction. Okay, guys, and then it says there is no friction acting between that and that, but part B has a rough surface. Now they're saying draw all the forces acting while it is from B to C. Now look at this. If it was just moving from A to B, the forces are done, nothing else is acting on this object. But from B to C, something changes. Now we are going to draw that free body diagram. So what you do, this is what is happening. Similarly, you have the normal, which is your N, still the same, and then you have your weight, which is acting downwards, or Fg, but now because there is friction on this object, then we can now add it here. So look at the difference there, which is our F. This is the difference now. So they wanted that answer. So you, when you're drawing a free body diagram, this is what you needed to draw. You just do that and then use a ruler. You do this and then you do that. Must be straight lines. Don't worry with the sizes as such. So that's what you need to draw, to say this is the weight, this is the normal, and then this is the friction. But now if you wanted to include, there are two forces that are hidden here that you can resolve, the weight of the object. So what you can do, if you wanted to include the weight of the object, this is what you do. You have that the normal doesn't change. Now the friction also doesn't change, but there is two forces that can represent this force, the weight. Now the weight you can resolve. Let me come back here. You can resolve this force. I'll make it dotted line to say if I go down horizontally like this, and then actually it's not going down horizontally, that yes, it's going down horizontal because it's friction, I mean the component of weight. This is what we call the weight parallel. Are you with me? Because it can roll on its own down. Remember, it's moving on its own. They told us here to say it is sliding down, so which means the gravity is the one that is causing this thing to slide down. So we call it the weight, the parallel component. And then I did draw it before. You've got that one which is at 90 degrees to the what? To the parallel component. We call this the perpendicular, which is weight perpendicular. Are you getting that? So if you wanted to include, you don't have to include the weight. Now this is how you put it. You're going to draw it like this. It must be in straight line with the what? With the friction, like that. And then this one must be in straight line with the normal. So you can have this force. Your diagram can still be like this. And then what you have, your normal, your weight perpendicular, your weight parallel, and then your friction. I prefer this diagram because all your working will be based on the second diagram. You'll see what I mean. Okay, now draw all forces 3 marks. That's why they gave it 3 marks. So where is the 3 marks? The 3 marks is here, the normal, that, and that. So when they're marking here, this is half, this is half, then this is that. Okay, so that's what they will do. Now finalizing this, guys, it says calculate the magnitude of the acceleration of the crate while it moves from A to B. From A to B. Look at the forces acting from A to B. Let me do it again. When we said you have that force, now if it's accelerating, we're looking at the force that are parallel to the plane, which is this force. We called it what? That force we said is the weight parallel. You see now the importance of that. And then is there any other force that is working on this? There is no other force. Only this force is actually causing this block to move this direction. So you are going to say weight parallel, right, is equal to what? MA. That's it. Weight parallel is equal to MA. But what is weight parallel? The parallel weight, remember, it's mg sine theta is equal to MA. Look, M and M is repeating. You can keep it, but I prefer to cancel it because nothing else is keeping it. But if you feel like it's confusing, let's leave it out and work it on it like that. So we say 25 times 9.8 sine what? Sine 15 is equal to MA, which is 25A. So the question wants what? Calculate the magnitude of the acceleration. So that's where now I'm saying you divide by 25, you divide by 25. See what I was saying to say? It's as good as cancelling that. So what is acceleration? Acceleration is 9,8 sine 15. So what is acceleration then? It is, if we do that, I think we're going to get 9,8 sine 15 is equal to what? 2,534. 2 decimal place, shift setup 6, and then 2 decimal place, which is what? ST 2,54. Now remember the units, meters per second squared. That's acceleration. Now downwards, you can even put the things to say it's accelerating downwards, right? And then next one is say write down the direction of the acceleration of the crate while it slows down from B to C. Now when it's slowing down, remember to slow down, that word already they are telling us something. When it slows down is what? Is deceleration. It means acceleration is what? Acceleration is equal to negative. So now they're saying write down the direction of the acceleration while it slows down from B to C. Write only up the slope or down the slope. So the acceleration, it is now up. Remember, it's slowing down, so it's opposing. The negative means it's opposing, so it's up the slope. Acceleration, but deceleration, this is deceleration. Deceleration here was down the slope. I hope you can just see the confusion they wanted to bring. Now acceleration is this one. Now the last question here says the magnitude of the net acceleration. Okay, there is the magnitude of the net acceleration from B to C is 1,2 meters per second squared. Calculate the magnitude of the frictional force acting on the crate. Now they are now at B to C, and I told you this is the diagram I prefer, and we are also focusing on this. Are you with me? And they want us to calculate what? Calculate the magnitude of the frictional force acting on the crate. You see, that's why you have frictional force. So you can come here and say, resolving this, you can say, let's first say take, I wanted the other, take downwards as positive. Let's just do that. Take downwards as positive. So you've got here weight parallel. Now is positive minus friction, which is going opposite direction, is equal to ma, always equal to the resultant, which is mass times acceleration. Remember, F net is equal to ma. Now weight parallel, we I think we did find it, which was here. Weight parallel was mg sine theta, which is mg sine 15. So we're gonna say mg sine theta minus F is equal to what? Ma. Now I know the mass. What is the mass of the object? It is 25. So here 25 times 9.8 sine, and the angle was what? 15 degrees, minus F is equal to 25 times acceleration. They told us now the acceleration. They said from B to C, the net acceleration. Now be careful, they didn't say deceleration. The net acceleration is 1,2, and they just told us where is it going. I said down the slope is what? Is positive. I said take down the slope is positive, but we said this thing is, the acceleration is up the slope, which means it's now negative. That's why they wanted to catch you. So use negative 1,2 there, because this thing is decelerating. It's acceleration, but in the negative. It was slowing down. Then from there, you can now simplify this. You can say what you have, 25 times 9,8 sine 15. So this is negative. When it crosses from negative, it will become positive. So it's plus 25 times 1,2. Now equal to, look, it's minus F. When it goes here, negative becomes positive, equal to F. You can just find the numbers here, find the numbers, and then do the normal way you want to calculate. I was just doing this to just get the answer first. Now look at this. So I'll get it as 25 times 9,8 sine 15 plus 25 times 1,2. Seeing that, equal to 93,41. So it's 93,41. 0.41 newtons. This is my friction. That's the frictional force. That's the frictional force of this. So okay, that's the frictional force, and that's what they wanted you to find out when they were asking you of that question. So calculate the magnitude of the frictional force. 5 marks, guys. As I said, this is what I wanted to bring to you in combination. Later I'm gonna bring to you these two electrostatics. Question 9 and 10 is also something similar. Just bring these as a combination so that you can have something that is combined, and just to show you how you approach this, and also give you this question on electricity. Those are the ones that I wanted to do. Then the other part of the question I'll do it later. So guys, we've come to the end of our lesson. I hope this was of benefit to you. If ever you're not subscribed, guys, I will encourage you to subscribe so that you can be notified every time I post a new video. We've come to the end of our lesson. Thank you.